All right. So what I wanted to do with you guys before we do your quiz today is to just go through the review 2 that you had for homework and make sure you guys are clear on everything that you need to know so that you can do the best you can on the quiz. All right, so first ones we're rewriting an exponential form. So that means we need to have exponents in our answers. So index comes to be the denominator of our fraction, so x to the 3/5. Over here we have more than one thing inside of our radical, so we put it in parentheses with the 1 outside, so that when we bring that index, we have 2x to the 3rd to the 1/5, and then we can put that 1/5 through 2 to the 1/5, and then here we have a power to a power, so it'll be x to the 3/5. Similar on number 3, parentheses around everything inside with a 1 outside of those parentheses, 3x squared to the 1/4, and then we put that 1/4 through, and again power to power, so we multiply. And here we can reduce this fraction, so we'll say 3 to the 1/4, x to the 1/2. Okay, number 4. Now when we already have something down there on the denominator inside of our radical, like we do on number 4, we multiply those numbers together. So 4 times 5 is 20. So we end up with x to the 2/20, which we can reduce to 1/10. Same thing on number 5. We have a 6 on the outside, a 4 that's already down there. So we have 3/24 when we multiply the 6 and the 4, and that can reduce to 1/8. And then here we have a 3 with a 7 already down there. So x to the 4/21, that doesn't reduce, so that's our answer. Okay, we also have rewriting in a radical form, which means we should have this symbol in all of our answers. That's what radical form means. So going the other way, the denominator becomes the index. So we'll have the 5th root of k squared. Here on number 8, it's a 2. So remember, we don't necessarily have to write the 2. When there's nothing there, it's assumed to be a 2. So we have the square root of y to the 3rd. If you want to write the 2, you can, but you do not have to write the 2. And then number 9, the 7th root of z squared. All right, so now let's get into the simplifying. And this one, again, exponential form, so our answers should all have exponents, not radicals. And so all of these contain both forms in the problem. So what do we do when we have both forms? We convert everything to exponential. So we have 7 to the 2/9 times 7 to the 2/3. Same base, so to multiply them, we just add the exponents. So 2/9 plus 2/3. We need to get a common denominator for our fractions in the exponent. So the common denominator will be 9. So I'll have to multiply this fraction, top and bottom, by 3, and I get 6/9. So 7 to the 8/9 would be my final answer. On number 11, it's the same thing. Convert first everything to exponential. So 3 to the 2/5, 3 to the 1/4. Same base being multiplied, so we have to add the exponents. And again, we need a common denominator. So in this case, it'll be 20. So this will become 8/20, and this will become 5/20. When we add them together, it gets 13/20, and that would be our final answer. Here we have division. So again, remember, if there's nothing written in the radical, it's a 2. So we have 5 to the 6/4 and 5 to the 1/2. Here we have the same base and we're dividing, which means we subtract the exponents. So we're going to have 6/4, which I can actually reduce to 3/2, minus 1/2. And that way I have my common denominator. So 3/2 minus 1/2 is 2/2. Well, 2/2 is 1, so here it would just be 5. Okay, the next set, we're doing the same thing, except we're leaving our answers in radical form. So we're going to do the problems with our exponent rules, and then we'll go ahead and at the end convert it to a radical. So like bases being multiplied, we add the exponents. We have to get a common denominator, which in this case it would be 12. So we'll have 4/12 plus 3/12, so 6 to the 7/12. But we have to do radical. So that means we're going to do the 12th root of 6 to the 7th. And then in your calculator you can figure out what is 6 to the 7th to get your final answer. On number 14, again, same base being multiplied. So we add the exponents. We need to get a common denominator. So in this case, let's do 30. Let's see, so 6/30, 5/30. Add them, you get 11/30. Change it to radical, we have the 30th root of 7 to the 11th power. 15, same thing, same base being multiplied, so we add the exponents. 1/5 plus 1/4. Got to get a common denominator, so in this case it'll be 20. Add the numerators and convert to a radical. And again, these numbers you can multiply out in your calculator to get the number itself, the actual number. All right, so the next group, so far it's been a lot of just converting back and forth and using some of our basic exponent rules. So the next group down here at the bottom, we had to evaluate. Now evaluate usually means your answer is a number. Okay, so we're not going to have an exponent, we're not going to have a radical, it most likely will be a number. And so when we have something like 9 to the 5/2, this is where we want to rewrite it as a radical. So I'm going to bring the 2, and then we have the square root of 9, and I'm going to put the 5th power on the outside of my radical. Because remember, we can either put it inside the radical or outside the radical. I can actually take the square root of 9. It gives me a pair of 3's. So the square root of 9 is 3, and we have that to the 5th power. And so then in your calculator, you would want to figure out what is 3 to the 5th. So 3 to the 5th would be 243. And that would be your answer. And so 17, we're going to do the same thing. Write it as a radical with the exponent on the outside. Break down 81. And because it's an index of 4, we're looking for a group of 4. So we'll have 3 to the 3rd, which is 27. And the last one here on this front page, again, write it as a radical. So we're going to do the cubed root of 27. Put the squared on the outside. Break down 27. We're looking for a group of 3, since our index is 3. I have 3 3's, giving me 3 squared, which is 9. And so whenever we have just a number as our base, we want to try to put it as a radical to simplify and then do our exponent at the end. So that way we can get it in as simple a form as possible. Okay, backside. Number 19, select the equivalent expression. So selecting the equivalent expression means we have to figure out which of these, and there might be more than one, simplify to the same thing. So what I'm going to do is take my expression here, and I'm going to try to simplify it using my exponent rules. So the 4 has to go to both of these. So 3 to the 4th, x to the 1/4 to the 4th. Well, 3 to the 4th is 81. When I have a power to a power, 1/4 times 4 will just give me x. And if we want, we can write the 1. We don't always have to. But which of these does it match? Matches letter D. Doesn't match any of the others, so we know we only have one answer. But just to keep in mind, you could potentially have more than one, depending on how your options are written. Okay, number 20. Select an equivalent expression. So here we're going to simplify. So there's a minus sign here. We have to distribute it into the parentheses. So -3 plus 3 root 10. And then I just copy this first one down. And like terms, so to be like terms, we're looking for same radical. So 4 root 10 and 3 root 10 can be added together to become 7 root 10 because they have the same radical. The 12 and the -3 can also be added together because they don't have a radical. So 12 minus 3 is 9. So 9 plus 7 root 10, that would give us option B. Okay, so 21. Determine which expression is equivalent to 8x to the 5/4. All right, so let's start by remembering, what does the 5/4 exponent go to? It's only on the x. So if it's only on the x, then only the x will have the radical. So right now, looking at this, I know for sure it's not going to match this one because they switched the index and the x, so it's not going to be that one. This one put 8 inside, which I know it shouldn't be. Okay, so now I got to think about these two. Well, these two are back in exponential form, and they don't look anything like my 8x to the 5/4. So what I'm going to do over here is I'm going to take option C, and I'm going to try to simplify this 16 to the 3/4 to see if I can get it to match 8. So if I write it as the 4th root of 16 to the 3rd power, the 4th root of 16, so 2, 8, 4, 2, 2, 2, I have 4 2's, so that's 2 to the 3rd, which is in fact 8. So this one, option C, does simplify to match what I was given. But I'm also going to check option D just in case. So do I have any way of reducing 16? The answer is no, because this already has a 1 exponent, where it was different than here, where I had the fractional exponent that could let me reduce. So I know there's no way I can get 16 to become 8, so my only answer is going to be C. All right, last set. We're simplifying, use only positive exponents. So that's another way of saying exponential form, not radical form. Okay, so let's see. I have a 3 on the outside of my parentheses. I'm going to put it to both. So x to the 6th, y to the 12th, and we're done. Same thing here. I have to put this 3 on the outside of my parentheses to each term on the inside. So I'm going to have -2 to the 3rd, power to power, x to the 9th, power to power, y to the 15th. Last step, what is -2 to the 3rd? So remember, that's -2 times -2 times -2. two negatives make a positive, but I still have one left over, so it's going to be negative. 2 times 2 is 4, 4 times 2 is 8, x to the 9th, y to the 15th. Okay, 24. Put the negative through to everything inside the parentheses, both on top and on bottom. So 2 to the negative 3, x to the negative 9, because again we have a power to a power, and y to the negative 12. Everything has a negative exponent, so that means everything flips. So we'll have y to the 12th on top, 2 to the 3rd on the bottom, and x to the 9th on the bottom. Last step, figure out what is 2 to the 3rd, and that's 8. Whoops, wrong letter. And then we still have our x to the 9th on the bottom and our y to the 12th on top. On 25, we're multiplying, but I do have an exponent outside the parentheses, so I have to put that exponent through before I multiply. So I have 7a to the 11th, b squared, times b to the 3rd, times negative 5 squared, a to the negative 6. So if I look at my b's, I can combine those, like bases being multiplied, by adding the exponents. Same thing with my a's. Like bases being multiplied, so 11 plus negative 6 will give me 5. And then my numbers, I have 7 times negative 5 squared is 25. So in your calculator, you can do 7 times 25, and you would get 175, a to the 5th, b to the 5th. All right, 26. So the numbers, remember, we can reduce those just like any other numbers when we divide. So is there a number that goes into both 32 and 4? Yeah, 4. So 4 goes into 4 once, it goes into 32 8 times. So I'm going to have an 8 on top and a 1 on the bottom for numbers. Next, I can make all my negative exponents positive. So x to the 4th is already positive, so I'm going to leave it on top. And I'm going to bring this x to the negative 5 to the top so I can make that 5 positive. I'm also going to bring the y to the 10th to the top to make it positive. And I'm going to move the y to the 3rd to the bottom to make it positive. Next, I'm going to combine my like bases. So 8 is still on top. 4 plus 5 is 9. Division, 10 minus 3 is 7. I'm left with nothing on the denominator because everything moved to the top, so we're done. Last one, 27. Put the exponent through to both of these before we start combining things. So this will become p to the negative 8, q to the 12th. We can add like bases together, or add the exponents of like bases. So 7 and negative 8 is negative 1. For q, we have negative 3 and 12, so that would give us 9. The p is still negative, has a negative exponent, so we're going to move that to the bottom, and we have our final answer. If you need more time, that was not for you. If you need more time, Mrs. Burton can just show you the answer key before, but you guys do need to start the quiz with about 20 minutes left in class.